The Schmidt number is a dimensionless number that relates the viscous to molecular diffusion. So it's defined this way, that there is a viscosity divided by the density and divided by the diffusivity. That's not diameter, it's diffusivity. And here are the properties, the actual values, and you see the viscosity here, density, and diffusivity all in different units. And so in order to calculate the Schmidt number, we have to make the units all consistent. If you put them in SI, CGS, or engineering units, it doesn't matter, you'd all come up with the same number. So the first step is to write it out as a picket fence. The Schmidt number is equal to, and I'm just going to draw a long picket fence because I know this is going to require quite a few unit conversions. We put the actual values in here, so 1.10 times 10 to the minus third Pascal seconds, and the density is 62.4 pound mass per cubic foot, and the diffusivity is 2.7. E to the minus fifth is the same thing as times 10 to the minus fifth centimeters squared per second. Now, when the picket fence takes up the whole width of the paper, then we just draw a continuation here. It probably will require quite a few things here. Once we have put all the values as given here, the next thing to do is to change everything into SI units. And so we're going to first off tackle the viscosity here. A Pascal is a Newton per square meter. So I'm going to write that here, a Pascal. I write it in the denominator so it cancels with the original pascals, is a Newton per square meter. The next thing we can do is go ahead and take care of the newtons using the G sub C. So a Newton is a kilogram meter per second squared. And now I'm going to do something about the engineering units and the density. So we have 2.20 pound mass per kilogram. And we need something for the cubic feet, so 35.3 cubic feet per cubic meter. And finally, that takes care of the density. Now finally we have the diffusivity, and we just have to put the centimeters in terms of meters. So we have 100 centimeters per meter, and we need centimeters squared, so I square the number and the units. Now, this should all cancel. So let's go ahead and try to cancel units, starting with pascals. The seconds, let's see, we have seconds squared here, and we have a second here and a second there. Cubic feet cancels out with the cubic feet here. Pound mass cancels with this. Centimeters squared cancels out with this square centimeter. The newtons cancel. Kilograms cancel. And I'm left with a meter and a meter cubed, so that's a meter to the fourth power, and here's a meter squared, and here's a meter squared. So all the units cancel out, and I can then calculate this to be 407. It's a dimensionless number, so it has no units. So to recount, we write for a single dimensional equation, we write out in a picket fence form the number with the units as given, and then we convert everything to SI units. I could, if I wanted to, convert everything to engineering units, but in this case I chose SI units. And sometimes it involves taking a derived quantity like the newtons and pascals and put them into more base units.